myself only. Right, and I am Sheshadri Gowrishankar. So I'm taking this presentation mainly because it started off from a myth, and what turned out at the end of it was something so astounding, and it changed the course of fluid mechanics, and something very worthy of talking about. So what is a myth? So a group of French mathematicians once over dinner, after having a little too much wine, decided that, yeah, on a piece of tissue paper, the bumblebee is too fat, it can't fly. It can't fly. And this myth carried on for the next 20, 30, 50 years. Okay, so now let us look at how objects in general fly. They fly because of the Bernoulli principle. It basically states that if fluid is moving faster, it has a lower pressure, if it's moving slower, it has a higher pressure, and so on. Right? So now, this is essentially what it is, right? It means that fluid flowing, etc. So now if they are symmetric, that means there will be no length, etc. Okay? So as the angle increases, what you find is that on the top you have a lower flowing, and on the bottom you have a higher flowing, and you can have increasing amount of lift. Right? So now if the angle continues to keep increasing, then what happens at one point of time is that no air can flow over the other side and the object stops. And this is known as stop. Okay? So now let us look at turbulence. Right? So basically over the course of years, engineers have tried to minimize turbulence. And turbulence essentially means that for an object, the air which flows doesn't come back at the end of the object. Right? So as a result, what you have is two different kinds of things. You have a formation of vortexes behind the object, which means basically there's a low pressure behind the object, or you can have velocity induced flow of air downwards, which means there's lesser lift and objects are being improved. Right? So now after this basic idea, let's look at why bumblebees shouldn't fly. Basically, they are very big, right? And they are very big and they have very small wings. So if they have to fly, the wings have to flap really fast for them to even stay afloat. So now if the wings have to flap really fast, what you find is that the energy for the bumblebee for it to do so would be very large, right? And so if the energy is very large, it cannot fly. Right? But every day, I'm sure some of you see insects or bumblebees flying around. So the question remains that what is so different about this that makes it fly? Okay, so it's supposed to be a video and it's not playing. There's no video. Cool. So anyway, so the video basically, the bee basically keeps moving its wings up and down, and there's a rotatory movement, right? So as the wings move, right, there's a formation of these vortexes because it's moving at a high angle of attack, which leads to this a low pressure on the top of the wing. As a result of this, there is a lift produced. But however, this is not a very stable thing because these vortexes then go behind the object, and then as we see earlier, it becomes a form of turbulence, and therefore reduces the lift on these objects. Right? And therefore, how does the bee manage to survive in this turbulent mode? So essentially, while it rotates its wings, which is like a 180 degrees rotation for the wings, it basically has an axial velocity, which means it throws some velocity towards the edge of the wing. And as a result of this, what happens is that the leading edge vortex which was formed becomes stable, and therefore you have a low pressure inducing lift. What they also found was experimentally during this wing rotation, I have some lift, and this is clearly not explained by the earlier phenomena. Okay, so what happens over here is essentially what happens in a cricket ball, for example. So what happens in a cricket ball is that as the ball rotates, it takes some amount of velocity above the ball, and the smaller chunk of velocity goes below the ball, and therefore there is a lift induced even when this object is rotating. Okay. So now, what is the purpose of this whole talk? The whole purpose was that these bees are operating in a turbulence mode, right? And therefore there is a lot of energy which is lost, which is why we are trying to minimize turbulence in the first place. So how does the bee manage to use this turbulence to its advantage? And this is what it does. So basically as the wing rotates, the entire vortex which is formed is shed, and this is the loss of energy. But then the region in between the two vortices has a high pressure, while the vortices themselves are of low pressure. So when it comes back into this region, it experiences a further lift which takes it forward. And this is where it's being used, right? So the US Army has spent $2.5 million to develop these tiny insects which have video cameras in them which can go into Iraq and see what is happening in the US Army. Okay, so now the end is that basically we have to learn from these insects, and I know it was a scientific talk and pretty boring, but at the end of the day, we have always thought that turbulence is a bad thing, and we have always tried to minimize it, and we have looked at everything from that one dimension. But then here come these insects, and they use turbulence to create something magnificent, to create that same flight which you earlier thought was something very good.